So first of all, what is biomolecule? Okay, so biomolecules are nothing but these are the substances which are very necessary or which are responsible for what? Growth, maintenance, and to sustain the ability of what? Reproduction. For example, it may be carbohydrates, proteins, fats, enzymes, or vitamins. So these are basically very essential molecules in order for any reaction to take place. Okay, so one of the largest biomolecules which we can see is nothing but the carbohydrates. Now, carbohydrates means what? The compounds which contains hydrates of the carbon are called as carbohydrates. So they will be having what? Hydrates of carbon. And the basic definition of carbohydrates is what? They are optically active polyhydroxy aldehydes or ketones, having the basic general formula as CX H2OY. Okay, now these carbohydrates are very important and they have been classified into two main sections. Okay, so if they ask you about the classification of carbohydrates, so they're classified into two main parts. Classification of carbohydrates. So first, they are classified either as a reducing agent or non-reducing agent. And secondly, they are classified as what? On the basis of hydrolysis. On the basis of hydrolysis. Okay, so if the classification of carbohydrates is according to the reducing agent and non-reducing agent, then we'll know that whether that substance is capable of reducing other agents or not. On the other hand, basis of hydrolysis means what? Hydrolysis means breakup, right, into smaller components. So splitting up. So if they are classified on the basis of hydrolysis, again, there are three types under it. Okay, that is monosaccharide. Just a second. Monosaccharide, oligosaccharides, and polysaccharides. Now, what is this saccharide? Saccharide meaning sugar. Okay, the meaning of saccharide is what? Sugar. Then mono. Mono means one. Then oligo means it will contain a units of 2 to 10. And poly means as many as it can. That is n number. Okay, so this is what the classification of carbohydrates. Now let's move on towards the detail of this. So first is what is reducing and non-reducing agent. Here it will be basically the sugars because all are saccharides. So therefore they will be what? Sugars. Sugars means saccharides. So first we'll see reducing sugars. Now in the name itself we can see reducing means what? These sugars will be having either a free aldehydic or ketonic group. Free aldehydic or ketonic group. Whereas non-reducing means they will not have a free aldehyde or ketonic group. No free aldehyde or ketone group. Okay, so this is the first difference between the two, reducing and non-reducing. Second difference is there are two types of solutions, okay, to determine whether the sugars are reducing or non-reducing. So one is called as the Fehling solution. And the other one is Tollens reagent. Okay, so if that sugars are capable to reduce both these solutions, that is Fehling's as well as Tollens reagent, then we say that these sugars are what? Reducing sugar. For example, maltose or lactose. So what will be the non-reducing sugar? They do not reduce these two solutions. So they do not reduce Fehling's, neither Tollens reagent. For example, we can take sucrose. Then next type is on the basis of hydrolysis. So as we saw that there are 3 points in this. So the first one is what? Monosaccharides. Monosaccharides. So as I told you, mono means single and saccharides means nothing but sugar. So monosaccharides means what? These are basically simple sugars. Okay, means for example, if I take glucose, okay, why they're called as simple sugars, I'll tell you, because they cannot be hydrolyzed further. So therefore they are called as what? Simple sugars. For example, glucose you can take. Okay, so this glucose, it cannot undergo further hydrolysis or further decomposition to give what? Simpler products. Therefore they are called as what? Monosaccharides. You can take either glucose or even fructose to this. Okay, then second one is oligosaccharides. Oligo means, as I told you, it will be having what? 2 to 10 units. So 2 to 10 units of carbon means what? Obviously, they are not simple sugars, correct? So when these oligosaccharides, they go under hydrolysis, they undergo what? Hydrolysis, and they will give the units of monosaccharides. So they are called as oligosaccharides. And the third one is polysaccharides. Polysaccharides means what? Those which have the capacity to hold more than 10 units of atoms, or whatever the groups are there. For example, you can take starch. Why starch? Because it contains n number of glucose molecules. So n number of glucose molecules together will form what? Starch. So therefore they are called as what? Polysaccharides, means many. Okay, so these are what the small classification of both carbohydrates, that is on the basis of reducing and non-reducing, as well as on the basis of hydrolysis. So in detail, we are going to study about the monosaccharides. Okay, so let's see what is monosaccharide and certain examples of the same. Now, as I already told you, free ketonic and aldehydic group, okay, means aldoses and ketones. What are they? So first of all, aldose. Okay, so aldoses means what? They are nothing but the monosaccharides which contain CHO as a functional group. They'll be having what? CHO as their functional group. So therefore they are called as aldoses. Then second one is ketones. Ketones means they will be having a ketonic group, and it is C double bond O. This is their functional group. Okay, so the monosaccharides, they are classified as what? Aldoses or ketones. Okay, so aldoses means what? They will be having the group that is CHO, therefore they are called as aldose, whereas ketones means they will be having the functional group that is C double bond O. So depending upon what type of functional group is present only, we are going to see the examples of glucose as well as what? Fructose. Okay, so I'll just draw the structure, a basic structure, then it'll be clear for you. For example, aldose. Aldose, how it will look like? CH2OH, CHOHN. And H. Okay, so this is how an aldose will look. In the same way, ketones, same thing, but just the basic structure difference is what? The functional group, that is CH2OH, then CHOH, and here you will be having C double bond O. Okay, so this is the only difference between what? Aldoses and ketones. So one is having CHO, as you can see over here, and here you will be having in the ketones, that is C double bond O. Okay, so if you want to differentiate between the two, that is which is a monosaccharide having aldose group and ketose group, so this is the best way you can do it. So if it's an aldose, it will be having CHO group, and if it's a ketone, it will be having what? C double bond O group, respectively. Okay, so whatever the ketone group is there, it's a divalent. Divalent means what? It can be present anywhere along the structure of the chain, that is anywhere along the C chain. Okay, but basically you will find this C double bond O will be present in the terminal side, that is at the end side, this side. Okay, you will find that C double bond O group will be present. This is in case of ketones. Why? Because ketones, they are always it's a group, it's a divalent group. So therefore, you will find them at the terminal C, that is nothing but the C2. Whereas aldose which are there, you will find it where in the C at the C1. Okay, so this is the basic difference how you can spot out what which is aldose and which is ketones. Okay, then the next one is examples of monosaccharides. So the first basic example, as I already told you, is what? Glucose. Okay. So what is the basic formula of glucose? C6H12O6. So glucose is a monosaccharide which occurs in a free form as well as combined form, and it is nothing but a particular type of sugar. So you will find this mostly in the ripened fruits and so on. So therefore glucose is mostly called as what? Grape sugar. Or you can also find these in honey and sweet fruits. Okay, so this is sugar which can occur in the free as well as in what? Combined sugar. Now, how is this glucose prepared? Okay, so there are basic two ways in which you can prepare glucose. Okay, so let's see the two ways. Preparation of glucose. Okay, so the first method of preparing glucose is from sucrose. Sucrose is nothing but also called as cane sugar. And the second method is by using starch. Okay, so these are the two methods by which you can prepare glucose. One is either you can use the sucrose, which is commonly termed as the cane sugar, or another one is commercially glucose can be prepared by using the second one, which is the starch. Okay, so the first one is what? From the sucrose. So what is the basic formula of sucrose? C12H22O11 with water will give you two molecules. Okay, one is C6H12O6. Another one is also same. I'll tell you what it is. So one is glucose and another one is fructose. Okay, so both are having the same formula, but there is difference. Okay, that we'll be studying later. Okay, so this is sucrose. Okay, so the sucrose in the presence of water, it will give you what? When it is hydrolyzed. And this one we are using HCl over here to hydrolyze it, or H2SO4 also you can use. Means either hydrochloric acid or sulfuric acid. So because we're using hydrochloric acid or sulfuric acid, therefore the condition over here is what? It's an alcoholic solution. Alcoholic solution. So if you want to prepare the glucose by using sucrose, okay, then what it is done is sucrose is hydrolyzed, okay, by boiling it with either HCl or dilute H2SO4. So both are not concentrated, both will be diluted in an alcoholic solution. Then you will get two molecules, one is of glucose and other one is of the fructose. So this is the first method of preparing it. Now the second method of preparing it is by using what? Starch. So if the glucose is prepared by starch, then it's actually the commercial method. Means in the industries, okay, people prepare the glucose by using what? Starch instead of the sucrose. So commercially, how the glucose is obtained is by the hydrolysis of the starch. So here what happens is the starch is hydrolyzed by boiling it with, again, dilute H2SO4, sulfuric acid, okay, at 393 Kelvin, at 2 to 3 atomic pressure, and it will give you glucose. Okay, now earlier only I told you starch is nothing but a form of polysaccharide. Polysaccharide of what? N number of glucose molecules. So obviously, if the starch is hydrolyzed, it is going to give you what? N number of glucose molecules. Therefore, I have written over here N. Okay, N number of glucose molecules. So these are the two methods by which you can prepare glucose. So is it clear to everyone? Till here, any doubt? Fine. So moving on. To the structure of glucose. Okay. Now, structure of glucose means you can see two structures basically over here in chemistry. That is, one is open chain, another one is the closed. That is cyclic structure also. Okay. So if I want to see the open chain structure of the glucose, how it is, I'll show you. Open chain. Okay, so whatever the formula is there, C6H12O6 of glucose. So according to that, this is the open chain structure that you're going to get. So here, first one is what? One aldehyde group. Aldehyde group it is having. Second is here 4 is there. So therefore 4 alcoholic groups. 4 alcoholic groups. And the bottom again, 1 alcoholic group. So this is basically was the open chain structure of a glucose according to its formula C6H12O6. Okay. Now, how will the cyclic structure of the glucose be? Now, when we see the cyclic structure of any monosaccharide, okay, it will be obviously in what? The closed form, correct? So that is what we are going to see, the cyclic form. Now, this, if this is the open chain form, how will be the cyclic form be? In a cyclic structure. So I'll just draw it and show to you. Cyclic structure. Cyclic structure means basically closed one. Okay, so if we see the cyclic form of any monosaccharide, there are usually two forms, okay, which we can observe over here. One is called as pyranose, another one is called as furanose. Okay, one is called as what? Pyranose, and another one is called as the furanose. So what is this pyranose and furanose? Pyranose means it will be having the structure like this. Okay, whereas furanose means 5. Furan means 5. Okay, so this is the basic difference between pyranose means what? 6 and furanose means 5. So the example which I can give you over here is, one is glucose, another one is fructose. Okay, so glucose can also be called as what? Glucopyranose, whereas the fructose can also be called as fructofuranose. Okay, why it's called as pyranose and furanose? Because of 6 and 5 digits. Okay, because if you're seeing the cyclic structure of glucose, So how it will be? It will be somewhat like this. HOH. Okay, just the open chain, I'm converting it to the closed one. So this is how the glucopyranose looks like. Whereas fructofuranose, how it will look like? The only difference will be here in the first carbon. Okay, HCH2OH. HOH. Okay, so this is the two cyclic structure of a monosaccharide. One is the glucopyranose, another one is the furanose, sorry.